The basic rationale for the application of lightning rods to protect storage tanks in NFPA 780 is expressed in a 1979 paper titled Lightning Protection of Buildings by Ralph Lee. Although the threat to storage tanks is correctly identified, the proposed solution doesn't actually address that threat. No sparks or a stroke, even a streamer from the ground up, can be permitted near a vent within the distance represented by the hazardous area boundaries. Okay, the hazardous area boundaries being the zone around a vent where flammable vapor may be present. Therefore, any sparking near or more likely from the vent itself could ignite that vapor. However, the proposed solution, to consider the whole volume of the hazardous space near the vent to be a structure to be protected, then protect this enlarged zone with rods, masts, and/or wires of the conventional type. This proposed solution does not actually address the identified threat. It may prevent a direct strike to the hazardous space, but all manner of sparks, streamers, and even leaders are still possible. Consider the following two images from a recent publication. Notice that 25 microseconds prior to connection, there are many upward discharges from many locations. But only one of these discharges connected with a descending lightning leader and conducted the lightning current to ground. In a way, the location that got hit acted like a lightning rod and prevented the other locations from being hit, but it did not prevent the other locations from producing discharges, even from the same building. These discharges may not have connected with any descending lightning leader, but they still had currents in the range of a few amps or more, not enough to damage a building, but more than enough to ignite flammable vapor. Consider the discharges from this building alone, which wasn't even hit by lightning. These are the effects of a nearby strike. The longest discharge seems to be coming from a mast or lightning rod installed on the roof. Other discharges are visible from other locations. One can imagine something similar happening to a tank battery. The longest discharge would be coming from the lightning protection system, but others, smaller but still hazardous sparking, could be coming from other locations. The lightning protection system may prevent the hazardous space from being struck directly, but it does not and cannot prevent most lightning-related sparking capable of igniting flammable vapor. It should also be noted that during this frame, which occurred in between the other two frames, when the lightning current was being conducted to ground and the brightness exceeded the camera settings, an electromagnetic pulse was created. This electromagnetic pulse likely generated sparking at even greater distances than the discharges that were visible under the descending lightning leader field. The only type of sparks that a direct strike protection system can prevent from or near a hazardous space are those sparks that actually connect with a descending lightning leader. Other forms of lightning-related sparking, which will occur more frequently, are unimpeded.